Problem number 42nd, part C and part D from chapter 26. Copper and aluminum are being considered for a high voltage transmission line that must carry a current of 50 ampere. The resistance per unit length is to be 0.150 ohm per kilometer. The densities of the copper and aluminum are 8,960 and 2,600 kilogram per cubic meter respectively. So here I already solved the part A and part B in the previous video. So in this video I am going to work out only for part C and part D. So what is your part C question? Compute the magnitude of the current density for an aluminum cable. And the second question, part D, is calculate the mass per unit length lambda for an aluminum cable. In the previous video, I solved the first two questions based on copper cable. So in this video, I am going to work out these two questions, part C and part D, for aluminum cable. And for that, we are going to use only the aluminum information. Clear? So aluminum information only I am going to consider for this question. So before that, I would like to write the given first. The current in the cable I, which is equal to 50 ampere, and the resistance per unit length, which is equal to 0.150 ohm per kilometer. So we have to convert the kilometer to meter. 1 kilometer is equal to 1000 meter. By that we can cancel this kilometer with kilometer. So we will get the resistance per unit length is equal to 1.5 multiply 10 power minus 4 ohm per meter. Now I am going to write the resistivity value as well as the density of an aluminum here. And here the resistivity and the density takes the same symbol rho. So don't get confused about which one is your resistivity value, which one is your density value, because both takes the same symbol rho. So I have to write it very clearly. The resistivity of an aluminum rho L, rho of Al, is equal to 2.75 multiply 10 power minus 8 ohm meter. So this is the constant value which will be given. But in the question, they did not mention the resistivity of the aluminum. Actually, this is the value for the aluminum resistivity. And also the density of an aluminum. Better I can put rho of D for aluminum. So don't get confused about these two values. So what is the density of an aluminum? Which is 2600 kilogram per cubic meter. So these are all the constant values they gave in the question. By using this, I'm going to find the current density of an aluminum cable. So let's start. As we already studied the equation for the current density J is equal to the current divided by area. For this area, I'm going to use the resistance equation, resistance which is equal to the resistivity of an aluminum multiplied by the length of an aluminum cable divided with the cross-sectional area of an aluminum. So I have to rearrange this equation in terms of the cross-sectional area. A is equal to the resistivity of an aluminum multiplied with the length of an aluminum divided with the resistance of an aluminum. So now I'm going to take this area equation, I'm going to substitute here. So by that, the current density equation is modified as current divided by the resistivity of an aluminum multiplied by length divided by the resistance, and this resistance will go to the top. Clear? So by that, your current density equation J is equal to current multiplied by the resistance divided by the resistivity of an aluminum multiplied by length. So the current is 50 ampere and the resistivity of an aluminum is a constant, which is 2.75 multiplied 10 power minus 8, and we already have the value for the resistance per unit length for both cable. Aluminum as well as the copper takes the same value of 1.5 multiplied 10 power minus 4 ohm per meter. This value. Clear? Now I'm going to substitute the value here. So J is equal to, the current value is 50 ampere divided by the resistivity of an aluminum is 2.75 multiplied 10 power minus 8 multiply with R over L value is 1.5 multiplied 10 power minus 4. Here I got an answer for the current density J is equal to 2.73 multiply 10 power plus 5 ampere per meter square. So this is the answer for part C. Clear? Now we have to answer for part D, which is mass per unit length lambda. So here I'm going to use the equation for density. As we already know, the density formula rho, which is equal to mass over volume. So here this is density of an aluminum. Now I'm going to rearrange this equation in terms of mass. Therefore, mass, which is equal to the density of an aluminum multiplied by the volume. I can write this volume as the density of an aluminum multiplied by area multiplied by length. So we can write the volume as area multiplied by length. We'll give the answer for the volume. So now what I'm going to do, I'm going to take this length and I'm going to move to the left hand side of the denominator. So therefore, the above equation will become M over L, which is equal to the density of an aluminum multiplied by area. So here, for this area, I'm going to use the resistance equation again, as we already used this equation in the previous part, or which is equal to the resistivity of an aluminum. So don't get confused about this row and this row. Okay, so here this row is the density and here this row is the resistivity. Clear? So don't get confused about this. So R, which is equal to the resistivity of an aluminum multiplied by the length of the aluminum cable divided with the cross-sectional area of the aluminum. So I have to rearrange this equation in terms of area. So area, which is equal to resistivity of an aluminum multiplied by length divided by the resistance. So now I'm going to take this equation, I'm going to substitute here. So if you substitute, the mass per unit length equation is modified as M over L, which is equal to the density of an aluminum multiplied with the resistivity of an aluminum multiplied by the length of an aluminum divided by the resistance of an aluminum. So here you have to see, here we have L over R. Actually in the questions we have resistance per length, but here it is an inverse of that, right? So for that we have to use the inverse value. What is the value of R over L? So we already converted the value of R over L in terms of ohm per meter as 1.5 multiplied 10 power minus 4 ohm per meter. So when you substitute this value, you have to take the inverse value. So now I'm going to substitute the value one by one. So what is the density of an aluminum, which is already given in the question as 2600 multiplied with the resistivity of an aluminum value is a constant, which is 2.75 multiplied 10 power minus 8 divided by this number, because this is L over R, which is the inverse value of R over L. So 1.5 multiplied 10 power minus 4. So here we got the answer for the mass per unit length, M over L, is equal to 0.477 kilogram per meter. Actually this mass over length is nothing but the lambda. So this is the answer for the part D. That's it. Thank you.